You are tasked to find all of the prime numbers from 1 to 100. How can we do this efficiently? Here's how. A prime number is a positive integer with exactly 2 factors. 1 does not fit that description, so 1 is out. The next number not erased is 2. 2 is prime, but all of its other multiples are not, so let's erase those. Then we look at the next number not erased, 3. 3 is prime, but all of its other multiples are not, so let's erase those. And we just continue this process. The next number not erased is 5, so 5 is prime, but all of its other multiples are not, so let's erase them. And let's do this one more time. 7 is the next number not erased, so 7 is prime, but all of its other multiples are not, so let's erase them. And believe it or not, we're done. Here are all of the prime numbers from 1 to 100. But how did I know to stop here? What we just did was called the sieve of Eratosthenes, which essentially says to find all prime numbers less than or equal to some number n, we just need to erase all of the multiples of the prime numbers less than or equal to the square root of n. N in our case is 100, so all we had to do was erase all of the multiples of prime numbers less than or equal to the square root of 100, which is 10. So we just needed to erase the multiples of 2, 3, 5, and 7 to find all of the prime numbers from 1 to 100. Now, how can we make sense of why we only look at the prime numbers less than or equal to the square root of n? Well, when we have 2 factors multiplying to a number, we can think of the square root of that number as the balancing point. One of the factors is always going to be less than or equal to the square root of that number. So when we're doing the sieve of Eratosthenes, if that number is not prime, it's going to be hit by a prime number less than or equal to the square root of that number. So there you have it, a quick way of finding all of the prime numbers from 1 to 100, and beyond if you wanted to.